Hello, my name is JAlfieri. I'm an EC 312, 332, and 342. And today I'm going to be talking about the KI5, about the receiver portion of the power and supply management system of a cell phone. We'll specifically be talking about how a received signal through the antenna is processed through the device, eventually going into the A to D converter to be converted into digital data that can be stored within the phone as audio files, video files, and whatnot. To start out with, I'm going to talk about the antenna and the duplexer, or diplexer, which were recently talked about in the last KI. In this case, the diplexer is set so that the antenna is in a receiving mode. What happens is the antenna acts as kind of a dipole antenna, so the frequencies that are picked up by the phones are within the several megahertz to the high gigahertz, so 2.2 to 2.4, depending on what carrier you have for your cell phone. Say, for example, you have a frequency of about 500 megahertz. Well, then, due to the relationship in the antenna size, you can find out that the antenna size is approximately half a meter, which is fine and all, but you look at your phone and you're like, where's the antenna? I don't see it. So basically, how we get the antenna into a phone is to actually compress it. And what we do is we basically have systems where the antenna is taken and wound up into a small area where the electrical length itself is still half a meter, but the actual physical dimensions is very small so that it can fit into a small device. So moving on to the bandpass filter. Once the antenna picks up that signal, a small little current is created within the antenna itself, which travels through the rest of the receiver system. This current is filled with many different frequency bands, and the point of the bandpass filter is to tune into that carrier frequency with the same bandwidth that allows for all the information being sent in that signal to be received. The rest of the frequencies around it, including noise, are going to be killed by this bandpass filter. To build this bandpass filter, you simply have a low-pass filter and cascade with a high-pass filter. Depending on the sequence of inductor and capacitors, you either make it low or high-pass filter. The more poles you have within this bandpass filter, the sharper your transition between the cutoff is for your bandpass filter. That also means it requires more power and money to create a device that has more capacitors and inductors. Moving on to the low noise amplifier. When the signal is received, it's traveled far away from wherever that the sending antenna was from, and so the signal itself has very, very low power or energy within it. And before you want to mix the signal with the carrier frequency, you want to be able to have that signal amplified enough so that it's not overwhelmed by the carrier frequency. And so the low noise amplifier amplifies that bandwidth that you have with your carrier frequency so that when you do mix it, it is not overwhelmed and can mix properly. So once the low noise amplifier amplifies the signal, the signal is then mixed with a local oscillator by the local oscillator frequency, which is the carrier frequency sent by the initial signal. And what this does is basically demodulates the signal so that you're left with just the baseband signal of the audio frequency, say 10 kilohertz, instead of that high frequency megahertz. And what it does is it basically causes the signal to be sent to the 0 point as well as to a 2 pi periodic frequency away from where the initial band was. and is again replicated on the negative side, which is not usually representative, but the other side has that negative 2 pi band way out there as well at the 0. So since the 0 has 2 received of those frequencies, it doubles the amplitude, so you have a much larger amplitude right at the 0 point. So again, the amplifier amplifies this middle signal so that it is a lot stronger and able to be processed by the A-to-D converter, as the signal needs to be strong enough. Otherwise, issues arise and it is not properly received in the system. Finally, the low-pass filter gets rid of those 2 outer bands that are not needed anymore, and you're just left with your signal at that very small frequency that is desired, so say 10 kilohertz, at that that is also amplitude enough so that it can be converted and stored as digital data in your system as audio, video, and whatnot files. It should also be noted that noise is present in the system at all times, including the received signal, as well as the amplification and every circuit component within the system itself. So when amplifying the signal, it should be noted to make sure that the amplifier is only amplifying the signal and not the noise. Otherwise, the noise can be interpreted as actual data and mess up the signal that's being received with the information. And that is it. Thanks for watching.